Okay, we're going to start our solving polynomial equations. One of the first things we want to look at here is steps for solving those. Basically, we want to get every term on the same side of the equation if it's a polynomial equation. The other side should be equal to 0, and then we're going to check to see if we can factor. Many of the ones that we'll give you in this section will factor. After we factor that, we'll set each factor equal to 0 and solve for the unknown. And if the quadratic's in the quadratic form, or part of it is, you can use your techniques for solving quadratics. So we're going to take a look at the first one here, and you'll notice that we have our equal sign here, and we have terms on either side. So we're going to bring all of the terms to one side. So I get 4x cubed. Now I would have to subtract a 6x squared from both sides and subtract a 10x from both sides. You'll notice if I get them all on one side, I now have them set equal to 0. I want to check to see if there is a common factor in all my terms, and in this case there is. I can factor out a 2x out of each one of my terms, and I'm left with 2x minus 3x minus 5, and that will all equal 0. Oops, this is a 2x squared. Sorry. Now, what we want to do from there is we want to look at factoring the rest of this polynomial, okay? And inside here we have a quadratic, and you can factor that by grouping if you were comfortable with that. I'm just going to go ahead and write it out and do it in my head, which some of you I'm sure are capable of doing. And we get 2x minus 5 and x plus 1, okay? Now that we have it factored, we can set each factor individually equal to 0. And if I solve these each for x, okay, I would divide by 2 here. I get x equals 0. If I add 5 and divide by 2, I get x equals 5 halves. If I subtract 1, I get x equals negative 1. And those are my answers. All of those answers would make this equation true. Okay? Let's take a look at the next one here. The next one, again, is a polynomial equation. Notice that all the terms aren't on the same side, so I'd need to subtract a 4x squared from both sides, and I would end up with this. Now, in this problem here, we're going to need to factor by grouping. And the way that I teach it, and I know it may be different people here, but I'm going to group. But whenever I group, I always group with a plus in between. So that's pretty simply remedied here. I'm just going to change, instead of having minus 7x, I'm going to make it plus negative 7x, because subtracting 7x or adding negative 7 is the same. Once I do that, I'm going to group the first two terms and the last two terms. I always want you to group. I would always suggest grouping with a positive in between. It avoids making some problems with the negative there. So if you go to group and there's a negative there, just change it to plus the opposite and group from there. Okay, in the first group, I'm going to factor out an x squared because I can, and I'm left with x minus 4. And in the second group, I'm going to factor out a negative 7, and I get x minus 4. And again, from your notes from factoring by grouping, you know that you want these two things, these two factors here, to match. That's the whole point of one of the main points of factoring by grouping. In this case, they do, so I can factor those out or undistribute this x minus 4, and I'm left with x squared minus 7. Now, those are this is now factored completely, okay? And what we can do is we can set each one of these individually equal to 0, okay? And solve for x. So if I add 4 here, I get x equals 4. There's one of my solutions. And I add 7, so I would get x squared equals 7. And then I would need to take the square root of both sides. And remember, when we take the square root of a positive number, or any number, we have a positive and a negative root. So there are my solutions.